That skill presents area of polygons. A polygon is a closed shape with straight edges. So a polygon could look like this, or this, or even a triangle is a polygon, or perhaps a square or a rectangle, you name it. As long as the shape is closed and the edges are straight, it qualifies as a polygon. In this video, we are going to talk about the areas of some special types of polygons. The area of a triangle is given by the formula 1/2 times its base times its height or the altitude. So if we have a triangle and this is the side that you want to name as the base, the height or the altitude is the perpendicular distance of the opposite vertex on the base. So this angle has to be a right angle or a 90 degrees. So all of this is the base and this is the height. Note that you are free to choose your own base for a particular triangle. So you can as well go ahead and say, no, I'm going to call this one the base. The only thing is the area will not change, because in that case the height of the triangle will no longer be this one. It will be the distance of this point from the base, and it can also mean that the perpendicular distance, if you draw that line, the height or the altitude can even lie outside the triangle. All you need to consider is that this angle out here has to be a 90 degrees. So if I want to call this side my base to find the area, like I said, I'm free to do that. Let me call it B2. And the area of the triangle obviously doesn't depend on the choice of our base. This is the new height. Let's call it H2, because the area of the triangle doesn't change. We have 1/2 times B times H is equal to 1/2 times B2 times H2. No matter whichever base you choose, if you know how to find the right height, you're always going to come up with the right answer. The area of a rectangle is equal to the product of its length and the width, also called the breadth. So if you have a rectangle, the opposite sides obviously are the same length. So let's call this L from here to here. And if this one is a W from here to here, this side is the same length as this side. So the area is going to be equal to L times W. And if the rectangle is a square, which essentially means L is equal to W, L times W is the same as L times L, which is L square. The area of a parallelogram is given as the product of its base times the height or the altitude. So it's pretty similar to what we have in case of a triangle without this 1/2 factor. So if we have a parallelogram, we know that the opposite sides are the same length in a parallelogram. If the length of this side is B, naming it as the base, the height again is the perpendicular distance from this vertex on the base. So this has to be a 90 degrees or a right angle. This is the height. Once again, you are free to choose your own base. So you could as well say that, okay, this is the base that I'm going to use. In that case, the height will change. The height will be the perpendicular distance of the opposite vertex on this base. So that this is a 90 degrees. And because the area of a shape doesn't depend on our choice of base, this times this is always going to be equal to this times this. Recall that a trapezium or a trapezoid is a shape with two parallel sides and the two other sides are not parallel. It's actually a quadrilateral, meaning it has got four sides. Two of the sides are parallel, the other two are not parallel. And the area of a trapezium is equal to 1/2 times the sum of the parallel sides, sum of the lengths of the parallel sides, times the distance or the height times the distance between the parallel sides. So if you go on to join these two parallel lines, you have a 90 degrees here. If this is a H, if this is a A, if this is a B, meaning all of this is a B, and from here to here is a A, we have this as 1/2 times A plus B times H. A circle doesn't seem to qualify as a polygon because it doesn't seem to have any edges, but having said that, you could also think of a circle as a polygon with an infinite number of small straight sides. So we are not going to get into that whether a circle is a polygon or not. Rather, we want to quickly review the formula for the area of a circle, which is defined as the number pi. It's a constant 3.14 times the square of the radius of the circle. And this constant pi is actually the ratio of the circumference to the diameter of any circle. Coming back to the formula though, this is what you call the radius of the circle. The distance from the center to any point on the circle, that's r. So you multiply r with itself and times that with pi, the constant, to get the area of a circle. Let's do a couple of problems. Find the area of a triangle with base 4 centimeters and altitude means the height. The height is 3 centimeters. We know that the formula for the area of a triangle is 1/2 times the base times the height. If we plug in the numbers, 1/2 times 4 centimeters times 3 centimeters, and if you cross off the 2 with the 4, that's a good habit to develop. Cross off common factors before you multiply. So the area is 2 times 3, which is 6 square centimeters or centimeters square. The lengths of the parallel sides in an isosceles trapezium are 10 centimeters and 16 centimeters. If the non-parallel sides are each 5 centimeters long, find the area of the trapezium. Recall that an isosceles trapezium is a trapezium in which the lengths of the two non-parallel sides are equal. So here we have a trapezium. These are the two parallel sides. And the lengths are given to be 10 centimeters and 16 centimeters. Obviously the one on the top, the smaller side, is the 10 centimeter side. From here to here is 10. And then all of this is a 16 centimeters. And it's also given that each of the non-parallel sides, so this one and this one, each one of them is 5 centimeters in length. Now we know that for a trapezium or a trapezoid, the area is given by 1/2 times the sum of the parallel sides. So I'm just going to go ahead and write 10 plus 16 times the distance between them. Now this is not given. The length of this line is actually the distance between the two parallel sides, provided this is a 90 degrees. And if that's a 90 degrees, we have another 90 degrees on the other side because the two angles are on the same straight line. Now if you call that h the height, we need to find that out in order to find the area of the trapezium. And to be able to do that, We note that if we draw the same height on the other side, now this shape inside the trapezium, this is a rectangle in which the opposite sides are the same length, which also means from here to here it's 10 centimeters. And therefore this has to be a 3 centimeters on either side, so that the total length is 16. And the moment we know that, we can apply the Pythagorean theorem on these two right triangles, any one of them, and say that the square of the hypotenuse over here is 5, so we could say 5 square is equal to the sum of the squares of the other two sides. This side is a 3, so 5 square is equal to 3 square plus 8 square. This is 25, this is 9 plus 8 square. So we have h is equal to, if you solve this equation, bring the 9 on the other side, you have 8 square is equal to 16, so h is equal to 4. This is equal to 4 centimeters. And now that you have the value of h, you can go ahead and plug it into the formula and find the area. So this is going to be 1/2 times 10 plus 16 is 26 times 4. Cross off the 2 and the 4, write a 2 here. So this is equal to 52 square centimeters.